So let's start with our first lecture on statistics. Um, so let's start with what is statistics? I'll just read from the definition I find online. Statistics is the study of how to collect, organize, analyze, and interpret numerical information from data. Uh, there are two main ones that we are going to be using: descriptive statistics and inferential. Okay, there are two types of statistics. Descriptive just gathers data and it looks at the average or variance or median, whatever kind of characteristics you can calculate from that data. Whereas inferential means that you try to use the data to predict something. It could be predicting something about a bigger population containing the data that you have, or it could also be predicting the future value of something. So we are going to have two types of inferential in this class. One will be the statistical testing, the second lecture part, where we're going to talk about hypothesis testing. And then in the later one, when we have the regression analysis, we will be able to use that for prediction, or sometimes use that for figuring out some missing data. Okay, now, but I guess the way I want to introduce statistics is like this. Statistics is like the most useful kind of math that you will be using, whether you're working in business or shipping, or if you're a scientist, you will be using statistics as the most useful math that you have. And that's because statistics often saves you money. So let's say you're running a business and you ran some kind of ad, okay? And you're not sure if this ad is useful. So uh, let's say you're trying to sell some children's product and you think, okay, I need to find the ad spot on PewDiePie on YouTube, right? Uh, and then you spent like hundreds or thousands of dollars, and a few months later, you want to see if this was effective or not, right? Now, one way you can do it is you can just look at the sales, but that's not everything. Sometimes you want to know the how much consumers noticed your product. So you might want to ask some households if they have children, whether they have seen this ad or not. That's the kind of things that you can do, right? But it's impossible to contact every child in the United States. That's going to be costing too much money. So instead of contacting every child, what you're going to do is you're going to get a few children, well, hopefully not just in your area, but like randomly sampled from every state or something. And then you get maybe thousands of kids. And from that data, you might be able to say, hey, our new product that we put ads on PewDiePie is very effective. Now the brand recognition is twice or three times as before. Then you can call it a success, right? So I guess when it comes to statistics, big, big important idea that you have to one big important idea that you have to know is the difference between a census and sample. Okay, and census takes all data. Okay, and sample takes a portion of the data. Okay, and then what are some pros and cons of census? So pros. Oh, so if you have you ever heard of the U.S. Census, population census? They do it every 10 years, right? And it's it costs a lot of money, but they need it in order to determine uh, like the uh, number of congressmen that should be assigned into this state or district, and how much federal tax money should go into this region. All of these things should be determined by the census, so it's important. They need that information, right? So they do the census, right? But I guess the cons is actually comes first. Cons of census is what? Costs a lot of money, yeah, right. Uh, and sometimes it's impossible. Sometimes, actually, a lot of times. So an example of such is like, let's say your company developed a vaccine, right? And you want to know the effectiveness of it, right? So if you're going with the census type, what are you supposed to do? You take everybody, take this vaccine, and we'll figure out how effective it is. Okay, that's not going to work, right? There will be rules against it, right? You have to do phase 1, 2, 3, 4 trials, and then at each trial you're limited to how many people you can have volunteers for. So sometimes by law it will be impossible, right? Okay. But why would you want to do the census? Yeah, it's more accurate. So for accuracy, yeah. Okay. And then the pros and cons of the sample is exactly the opposite of this. So pros and cons would be pros would be it's cost effective, right? And uh, feasible. Okay. Yeah. You can't sample everybody. You can't get data from everybody. Sometimes it's impossible, but in a lot of cases, getting samples is feasible. Right? And the cons would be there will be a sampling error. Okay, because you are getting only the values from the sample. Inevitably, your value that you get from here wouldn't match the actual value that you're going after. Like, for example, uh, let's say you want to know the population of United States that's smoking, right? If you use census, then you can get the exact number of people that's smoking. Here, you can't. You can only, let's say you sampled 1,000 people and you found out that maybe 100 people smoked, then you multiply by that. That's like 10%. So you multiply 10% by the entire U.S. population, and you get some estimated value for it, right? So you can't. You end up with some kind of sampling error. If your sample happened to be from a region uh, where a lot of people are smoking, then your value will be overestimating or sometimes be underestimating. So that's what's going to happen, right? Okay. And actually, that I think that's a very good example that I just came up with this number of smokers in the United States. Uh, so let's talk about individuals and values. Okay, so if you understood that statistics is about getting data, whether it's from a census and a sample, and in many cases, it's this problem because we end up having to work with samples. That's most likely what you have. So from this sample, to describe what's going on with this sample, we need some more words. And actually, this first lecture, you won't see any kind of math. It will be mostly terminology. But the terminologies that I introduced today will be very important in understanding what's going on afterwards, because I know that some students are so worried about math that they take this class and later on they do the calculation, but if I ask a conceptual question, so what does your calculation do? Some people have no idea what they just did. They just memorized stuff, formulas, and punched in numbers, and they don't know what it means. You need to have the correct vocabulary in order to understand what's going on later. So I'm going to throw in a lot of words today. So descriptive, inferential, census, sample, and now we're up to individuals and values, right? So first, individual is each individual or objects of the sample or census. Okay. But every person would come with some values, some characteristic values for it, right? So value is any characteristic, okay, or could be numeric or non-numeric, attached to each individual. So in a census, what goes on a census in the United States? They ask you for the race, are you race, ethnicity, how many people live in your household, what else? Your income level, all kinds of things are asked inside the census, right? And that one, that's the value. So each individual or each household in a census will be getting that census questionnaire, okay? And usually the head of the household will fill in that questionnaire. And when they write all the things like the race or ethnicity, that will be non-numeric, right? But the number of people in your household will be numeric. So those are what we call the values, right? So you can see that for each individual, you can have many different values, right? Okay. Now, when we track statistics, when we work with values, let me change the color, it's kind of dull. So there are types of values. Okay, first is broadly, you can say qualitative versus quantitative. And I guess I don't have to actually explain it, right? If I say qualitative, quantitative, you know what it means. Quantitative will be numeric. Qualitative will be like race, ethnicity, it will be non-numeric. And then there are, even in the qualitative, there are two kinds of qualitative data. So there's the nominal data, and there's the ordinal data. Okay. All right. So nominal data will be like names, which state that person's from, right? Which district, okay? Things that you can put names on it, but that's it. A lot of these are like categorical data. Right? On the other hand, ordinal data is, there are some cases where even if it's not, oh, I have to be careful when I said numeric and non-numeric. Sometimes even it's numeric, it's not quantitative, it's qualitative. And so an example of such is like your student ID. Yeah, it's a numeric data, but it doesn't quantify. It's the value itself has no meaning, right? So student ID will be a case when it's qualitative, not quantitative, right? Okay, and it will even be nominal because, well, that's a little hard to say because if your student ID number is bigger, then that means you're probably admitted to this school later than before. So I guess, yeah. But so going back to this, what's an ordinal data? This will be like grades. That's an A, B, C, D, F. Yeah, the one that you hate, F, right? Yeah. So I don't know which one you're going after for this class, but if at the end of the semester, if I have the student names and I have all the columns of final grade for this class, it'll be A, B, C, D. These won't be quantitative because it doesn't have a quantity to it, right? But you know that A is higher grade than B, B is higher grade than C, and so on and so on. So this will be a case where you have an ordinal data, which is qualitative, right? So there are nominal data and ordinal data. Let's put here names. Ethnicity. Okay. So that part should be not so hard to understand. Whereas in quantitative, there are actually two kinds. And this, I guess, this is slightly harder. I think this is the hardest until, I mean, everything I explained so far, I think this is the hardest one. There's the interval and there's the ratio. Let me just check my notes. Right. Yeah. So there's the interval variable and the ratio variable. Yes.
Ordinal is it like grades of each person?
Ordinal is when you have a non-numeric value, but the order does matter. Okay. Yeah. So interval is, this is when there is no zero, no absolute zero or zero. so that ratio doesn't mean anything. Ratio is meaningless. Okay. Uh, so here, let me explain what I mean by that. If you say, oh, the temperature from inside to outside is, they differ by 50 degrees Fahrenheit. I think it is something like that right now, or 40 degrees Fahrenheit. Then the difference does make sense. So when you have temperature, the difference does make sense. But if you say, oh, the temperature here is 3 times hotter than outside, you might think, well, it it may make sense, but it's a bit hard to say justify that statement because uh, if you translate that Fahrenheit into Celsius, it's no longer true, right? Is there a natural zero to temperature? It's hard to say. If you say Kelvin, then that's a good number. That will be that's something that you can process as a ratio. But if you measure temperature in Celsius and or Fahrenheit, it doesn't have a natural zero. Okay, you don't have a zero. Another example will be like in history, year of when something and something took place. Okay, so if you say, well, COVID-19 first appeared in year 2019, that 2019 value you think will it would would be, I mean, you can say, oh, it's been 3 years since it's been like 2.11 years since COVID-19 was first reported. So the difference does make sense, whereas the ratio doesn't make sense because what is year zero? It's like people first started out by saying, oh, Jesus Christ is the most important person, so let's put his birth date as 0 AD. Although later people found out that it's probably like 4 BC. But anyways, that's how people came up with that number, right? And you could very well start with a different kind of system. Uh, so there is no natural zero to the years. Okay, so uh, a good example of interval values would be temperature and time. Okay, what's a little confusing is that so ratio here is uh, there is a natural zero, and ratio makes sense. And an example of with this would be the age of a person, right? I'm twice as old as you, probably right. No, actually, maybe more, I think. All right, but anyways, uh, that would be okay, right? It does make sense. So age would be a ratio variable rather than an interval variable, okay? Because we can talk about the ratio and it does make sense, okay? And if you think about zero age, there is a well-defined zero age, right? If you're the moment you're born, that's zero, okay? So that's the difference between an interval variable and a ratio variable. Does that make sense? Okay, all right. Okay, so that's like the hardest one that I explained so far. All right. Now let's talk about sampling. Oh, before I do the sampling, now I'm going to talk about versus parameter versus statistic or sample statistic. Okay, and for this, we can come back to this example of number of smokers in United States. Okay, so when you really want the absolutely correct value of number of smokers in the United States, do you take census or sample? Census, okay? Then the number of smokers that you get out of that is what we call the parameter. So this is the value or true value obtained from all population. Okay. Whereas when you say I have a statistic, that means you have the sample value obtained from sample. Okay. And in many cases, your sample statistic will be close to the parameter. So if I say the absolute number of people that's smoking, then it would be very different, right? But if we talk about the proportion of people who are smoking, it will be pretty similar as long as you get a good sample, right? So if I picked 1,000 random adults from like with representation from like states like Hawaii, Alaska, every state with every different age. If I sampled well, then the percentage of people that are smoking there would be very similar to the percentage of the people smoking of the entire United States population. Don't you think? Do you agree? Right? Now, uh, how confident would you be if you had just 100 samples? How confident would you be of the proportion that you get out of 100? Not much, right? How confident would you be if you sampled 10,000 people? A lot more, right? You would be a lot more confident of what's going on with the entire population if you had bigger sample size, right? So guessing the true value from the sample value, this process is where we put most of the work. Yeah. Statistics. We put most of the work. I mean, the reason why we learn statistics is because we want to get the parameter from the statistic. Yeah. That's the whole business, okay? Now, once again, why don't we have parameter but only statistic? Because we lack the money, time, resources, even sometimes it's impossible, right? So with the power of statistics, we have some good idea of what the parameter would be, and actually you're going to see some surprising results. If the sample is done well, then even with just 1,000 people, you get a pretty good idea of what's happening to a population of 400 million. That's the power of statistics. Okay? That's something that you're going to learn later in this course. And this specific act of getting trying to estimate the true value from sample is called drawing inferences. Okay, it's like making inferences. Okay, you can make inferences about the entire population just from this sample, right? Now, when you do this, obviously you're going to have some errors, right? And I said there's the first the sampling error, and this is inevitable. It's just the limitation being that you don't have the entire population's data, right? But there are some other types of error which you could avoid. And one is called the non-sampling error. And these are avoidable errors. And that's like things like asking the wrong person. Okay. So let's say you were really interested in adults smoking population, and if your list of people contained cell phone numbers of 15, 16-year-olds, well, I know some of you still smoked in 16 years old or vaped or whatever, but if that wasn't the goal, right, then you shouldn't be including those individuals, right? So that would be like non-sampling error. So inclusion of wrong people, inclusion of wrong individual. That could be one. Or it could be like you have some questionnaire, and the question might be somewhat biased. Like you might be asking a political question, but then you would twist it so that it would mention the recent debacle or something stupid that politician did, right? So it could be some bias in questionnaire and a lot of different things. Okay, so there are some non-sampling errors that you have to look out for, and because it is possible to avoid this type of error, you should try to avoid non-sampling error at all costs. Okay, but then there's another type of error which is called random non-sampling error. And that's when your sample collection was biased. Okay, that's when your sample collection was biased. Now, when can such a thing happen? Well, let's say you're trying to figure out the average height of uh, male maritime students. Okay, all right, and you just walk by over there, and you saw like group of 10 people running, and you stop them. Hey, stop! I'm Dr. On. You should stop. Okay, you know who I am, right? Okay, and then I'm going to ask them, what's your height? What's your height? I get their heights and then take the average and then say, okay, so this is the average height of maritime students, right? Uh, Now that's not good, because maybe what happened was that people who were running were in the athlete, or they might have been all athletes, and maybe it was a specific type, maybe it was basketball team, right? Yeah. So I got the wrong group, right? So that in that case, there's a bias, right? So yes.
I have a question with the types of error, bias, and questionnaire. Could you explain that one more time?
Right. So this bias is bias in the question. It's like twisting in some people, some surveys actually do that. They actually twist the words so that the outcome would be not so favorable. Or let's say like a question for Obamacare, right? they might say, okay, this Obamacare will be raising your taxes by something, something. Now, do you agree with Obamacare? Then clearly it's going to be biased against it, right? Uh, but here is the bias is in the way that you collect the sample. That's the difference. Okay, good question. Thank you. Right now, so because of this, we have to think about sampling methods. So let's talk about sampling methods. And sorry, I took too long. This will be the last topic: sampling methods. And the first is cluster sampling. And this is sample being obtained from a few clusters. Okay. Um, so like what I just said, a group of people running, right? I stop them and ask for their height, right? There'll be a cluster sample because I just happened to see them and they were all together, right? Now, if I ask all the students in here, ask what their height is, and I just ask the male students, right? Then that's also cluster sampling, right? But I don't think it will have a bias, right? Because I don't think there's any height requirement in taking statistics course, right? Nobody says, oh, you're too tall, you don't come into this class. You know, we don't have, the seats are too small here. It doesn't work like that. So because of that, like cluster sampling is in many cases bad, but sometimes it's okay, right? So so I can't say it's always biased, but there's a possibility of bias. Right. Now, another similar kind of sampling, sometimes hard to distinguish the two, is called convenience sampling. And convenience sampling would be like you just make a web page and do a poll. Like, yeah, do you like do you like Shake Shack burgers? Okay. Click. Okay. Now, it's very convenient because you don't have to put a lot of money to make that website. It's just, yeah. But you have no idea who's visiting that website, what age group that is, right? So it can easily be biased. Okay, so convenience sampling is samples that are easy to get. Again, possibly biased. Now, I'm a Korean national, and so I sometimes track Korean news right now. And the big thing right now is we have a few presidential candidates, and Koreans love surveys. So every day that you would see new survey coming out, like, oh, this candidate is stronger than the other guys, and you could see two surveys that came out on the same day that was done in the same period that has opposite results. And if you look at why that happened, is because one survey just randomly called landlines, right? The other survey, they tried really hard to make sure that every age group is represented. Now, it's most likely that the older age groups are still using landlines. How many of you still have landlines in your home? Not many, right? And and it's more likely that people are retired staying at home that will be receiving that phone call. So you would see that the convenience sampling would actually bias the survey because you're going to get older people, right? So that's again possibly biased. Okay. All right. Then you might ask, okay, if these are bad, then what are some good ones? Well, here's a good one: systematic sampling. This is like you put the list of people in order, and you pick every 10th in the list, okay, and then call that number. Okay, that would be systematic, right? Okay. Now, of course, if your telephone list is again biased towards the older people, then it's still bad. But if you, let's say, if you're manufacturing cars and you want to know how many cars that you manufacture have certain problems, and then you can't test all the cars that you make. So what do? You take every 10th car. In that case, that would be pretty good. I think that's a pretty logical way, like reasonable way to sample so that it's not biased, right? So systematic sampling is like uh, every nth object is sampled, or nth individual is sampled. Okay, and then there's the stratified sampling. And let me write it here. That's when the stratified sampling is when the population is divided into subgroups and then sampled. Okay, so that every representation is there. So in this group, if I just wanted the average of all the students' heights, then since I see 4 females here, I will divide first by 4 females and the rest guys here, and then males and females, and then I'll probably randomly select 1 female, and from here, maybe select 5 males, so that I'm making sure that at least 1 female is represented, right? They'll be stratified, okay? But often, even if you divide into subgroups, the number of samples that you draw from each group is, you want to make it so that the proportion is similar to the group size, so that you don't overrepresent one group over the other, okay? So that's stratified. Makes sense, right? So you can see that these two kind of sampling would sometimes be hard to do, but it's less biased. Okay. Now, what is the best sampling? So the best sampling is what we call the simple random sample. Okay. Often abbreviated as SRS. Okay. So if you say, oh, SRS sample, that means that a sampling method where all sample size of sample size n, sample of sample size n, sorry, sample of sample size n is equally likely. Now, what kind of sampling is that? Well, let's say I want to pick 5 random guys from in this room, okay? And if you're trying to do the sampling method as SRS, what you're doing is I would put everyone's student ID numbers on like a golf ball, right? So I'll bring golf balls and I put student ID numbers on there, right? Put them into a large box. I'm going to shake that box, get five golf balls out, and then from there, I announce who was picked, right? That would be simple random sample. Okay, it takes a lot more work